Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing a hexadecimal number system. This lecture is designed to introduce the number system called hexadecimal number system, or simply this number system is also known as hex number system. So in the previous lectures, we had discussed about decimal number system, binary number system and octal number system. So this hexadecimal number system is also a very familiar number system in the field of electronics and other applications. As we all know, a number system is defined based upon the radix or the base value used on that particular number system. So in this hexadecimal number system, the base or the radix used in this hexadecimal number system is 16. And since the radix value is 16, we can simply tell that there are 16 different characters which are used to represent each and every digit or a particular unit in this number system. So in the previous lecture, we had discussed how to find the total number of available digits in a particular number system. So the equation for that is that range of a number system will always range from 0 to radix minus 1. 0 to radix minus 1. So the range will be 0 to, here the radix value is 16. So 0 to 16 minus 1, which is equal to 0 to 15. So the total range of numbers available in a hexadecimal number system is 0, 1, 2, 3, etc. up to 15. So now I am writing the numbers ranging from 0 to 15 in a decimal number system. So decimal numbers range from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So the hexadecimal equivalent of these 15 decimal So the hexadecimal equivalent of these 16 decimal numbers, that is ranging from 0 to 15, is equivalent to, so the decimal number 0 is represented in hexadecimal as 0 itself. 1 is also 1, 2, 3, 4, 5, 6, 7, 8 and 9. When it comes to the decimal number 10, the hexadecimal equivalent of 10 is A. Hexadecimal equivalent of the decimal number 11 is B. Hexadecimal equivalent of 12 is C. 13 is D. 14 is E and 15 is F. So the hexadecimal number system has 16 different representations, which is ranging from 0 to 9 and from A to F. So we can simply tell that the base or radix of this hexadecimal or hex number system is 16. The range of numbers are from 0 to 15, which can be represented, the digits in number system, the digit in hexadecimal representations are 0, 1, etc. up to 9 and A, B, C, D, E and F. So there are 16 different digits which is ranging from 0 to 9 and from A to F. This is how we are representing a hexadecimal number systems. And now we want to know why these hexadecimal numbers are introduced in the field of digital electronics or in mathematics. So as we all know, the digital devices or the computer devices are mainly representing the binary number system, as these devices can easily read the data using the binary on and off position. That's why the digital devices are using binary number system. But for a human, this binary number system is very tough or very vast to by heart or understand. That's why we are using decimal, octal or this hexadecimal number system. So in the previous lectures, we had discussed about the octal number system, which is used to read the particular binary numbers in an octal representation. Similarly, these hexadecimal numbers are also using to read or represent the binary numbers into a human readable form. So we can simply tell that these hexadecimal numbers are used to represent these binary value in an easy way. Each digit in a hexadecimal can represent 4 binary digits. Suppose a binary value is 0000. This representation can be easily done by using a single hexadecimal representation, one hex value. So 4 binary numbers can be represented by using a single hexadecimal. This 4-bit representation can also be termed as a nibble. So 4 bits or one nibble, N-I-B-B-L-E, nibble is equivalent to one hexadecimal digit, one hex digit. So one hexadecimal digit or one hex digit can represent one nibble or 4 binary digits or bits. So as we discussed, the 4 binary digits or bits can be represented by using a single hexadecimal digit. We can simply tell that a byte of data or 8-bit can be represented by using 2 hexadecimal representation. So the 8-bit representation or a byte representation is one of the fundamental representation in a digital device. So this representation can be easily done by using 2 hexadecimal representing numbers. So the binary 8-bit or a byte representation always ranges from 8 zeros to 8 1. This can be easily represented by using the hexadecimal representation 00 to FF. So we can shorten or simplify the binary number system in a digital device. So some of the applications are, of course, the first application itself is shorten or reduce the binary representation into a human readable hexadecimal representation. Another representations are, as we all know, all the digital devices are using the term pixel. So these pixel values are used to represent how the data or colors are represented in a digital device. So these pixel representations are always formulated by using this hexadecimal representation. Every pixel we can see a representation hash RRGGBB. So this R stands for red, G for green and B for blue. These primary colors are always represented in a digital device by using this hexadecimal representation and its intercommunications. And also, when we search in a particular search engine or a particular website or a browser, we can see a URL, Uniform Resource Locator. These URLs are very long in nature and these URL represent the actual site or the place where a website is loaded in a server. These URLs are very long in its nature. These URLs are shortened by using the hexadecimal representation. Next time when you search in a Google or a particular website, you can see, for example, suppose I'm searching in a Google for something, google.com/# or some values F13 bar UL dot something. So these representations are hexadecimal representations. If we are representing in a binary term, these will be very long in nature. So shortening or making this URL into a tiny URL, we are using hexadecimal representation in a browser or browsing or internet environment. That is another example. And also every hardware devices we can see a MAC ID or media access control ID. These MAC IDs are 12-digit long numbers. These numbers are unique for a particular device. These MAC ID representations are always represented in hexadecimal number system. So these are some of the applications of the hexadecimal number system. So when we conclude, we can tell that a hexadecimal number system is having a base or a radix of 16. So that simply means total available numbers in a hexadecimal numbers are 16, which is ranging from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Instead of writing 10, we are writing A. Instead of 11, we are writing B. 12 is represented as C, 13 is represented as D, 14 is represented as E and 15 is represented as F. That is simply we can tell the ranges are from 0 to 9 and from A to F. This is a hexadecimal number system which is used to read a particular binary number system into a human readable or human understandable form. In the upcoming lecture, we will discuss about how to convert a decimal number into a hexadecimal number. Hope you had understood this topic. So see you soon. Until then, goodbye. Thank you and all the best.